Welcome. My name is Ángel Gerardo Zaragoza Costa. I'm a student from the University of Universidad Politécnica de Piedras Negras, and today I'm going to present this piece that I'm showing here in this PDF. This is for my test of the Unit 2 in my university, so I'm going to start programming in this program that is called DOSBox. It's a CNC programming. So first thing I'm going to do is to establish my sequence of the main program. I'm going to divide this main program in two parts, one for the perimeter and the next one for the area of this figure. As you can see here, we have a square in the middle of this piece, and it's 120 millimeters and another 120 millimeters for both area because it's a square. And I already marked these yellow points just for my reference to the perimeter of this irregular figure. This figure has, as you can see here, uh, a depth of 5. So we are going to consider that we are going to do in this part. In my reference, I'm going to establish that, as already said, two subroutines, one for the perimeter and another for the area. The first thing we have to do here is to establish our billet or the side of the billet. We're going to write billet, and we're going to mark the length of all the axes, considering that this one as the x axis. I'm sorry, x, and this one for the y axis. And of course, as it's three squares, we happen to have the same for the y and x. And as I already said here, let's say that it has a depth of a depth of 10 in the zeta axis. Next one is to establish our tool. We're going to write tool depth T1 because it's going to be our first tool, and we are going to use just one tool, that is a tool of 10 of diameter, or let's say a radius of 5. Of course, um, I'm sorry. We're going to write here that is going to have a diameter of 10, and it's going to have a length of 0 of 10 too. I'm sorry. Next one, I'm going to start counting toward my sequence of the main program. We're going to have the write in each time 10 in 10 each time. So we're going to start to programming of first setup that is always using in all the codes for the CNC codes. And our first code is going to be using this one. This code, it is always used in all the codes. Basically, it's just marking the first setup, and we're going to use a absolute coordinate code because here we're going to study that this is a 0 point in all the axes. I mean for the x and y. And next one we're going to write the home. It's going to write U0, W0. Next one is going to write the M6. This code is used to establish that we're going to use the a tool that we established here. So this tool is the diameter 10, so it's a radius of 5. As I said before, it's because we have a clear radio of 5, so it's going to be more convenient for us to use this size for tool. Next one, we're going to write the velocity the of this machine. It's a standard velocity. It depends of the material and depends of the tool that we are going to use. So this value can change depending of the programming of materials. This one is going to establish our first point. First, we need to say that we have to establish um, a security length from the build rate, because obviously we don't want to cut in an area that it's not necessary to cut. So first, I'm going to establish here that it's going to be 1 millimeter over the billet. And next one, we are going to establish the first coordinate that is going to be this one. This one is 7 in the x-axis, but we have a radio of 5. So we have to consider that we have the diameter of 10. So center of the circle of the O2 is going to be the radio of this tool. So we have always to add or subtract depending of the tool that we are using. In this case, we have a radio of 5. So we have 7 plus 5 is going to be 12. 12 in the x-axis. And for this point in the y-axis, we have here we have 7, aquí va 20, so it's 27, minus, because we have to establish less than the 27, is going to be 22 in the y-axis. Next one, we are going to start putting here, we're gonna have a little dip in this part because we're going to start putting. Next one, let's say that this is the subroutine of the perimeter. And of course, this is not going to be read by the programming. Just it's a commentary, and when we add the parentheses inside, it's a comment for the code. Okay, as I said before, we're going to start this part of the perimeter, but we're going to establish that we're going to use a subroutine. How we use a subroutine? We are going to use this M90, A90, 90, 98 to establish that we're going to use a subroutine. This times is going to be repeated 5 times because the dip of this figure is 5. So it's going to repeat 5 times. And I already marked the subroutines in another carpets. So in this at least for the simulator, we have to close and open again a new document. but I already marked it before to not less than time. Okay, I call this subroutine this one 1,800 because in this this is the practice 18. Then we're going to start to programming. Well, first saving this file of the subroutine, and we're going to open using F3 to load the next subroutine. The subroutine is going to start for each point in the align marker here. Okay, um, as we mark it in the yellow points, and here we have to have a div of 5. We're going to have a div each time of cutting of 1 millimeter. The document say that we can do it in 2 millimeters, but I'm going to use it by each one 1 millimeter because it's a odd number. So we're going to use G91 to establish is an incremental coordinates, and we're going to down minus zeta, and we're going to add this G90 to stop the incremental. So in this part of the code, we are going to establish that each time that the loop is going to repeat, it's going to down 1 in zeta. Then our perimeter. Our first point, as we wrote in the main routine, is going to be 12 in the X and 22 in the Y. This is the first point that's going to be this one. Next one is we're going to down 212 in the x-axis because we have here that we have 7 plus the 2 is 12. So we're going we it's not necessary to write the again the if we have the same coordinate in each of the x or y of theta axis. So we're just going to write 12 in the y-axis. Next one, I'm going to go to this point. So this one is 7 plus 100 minus the 2 is 102. Next one is this one. So is y. I forgot to add this one. It's necessary to put this for this we have a code. And don't forget that we are going to use a G01 each time that we put a coordinate because we don't have a mess in the machine outputting. So we have to go to the same up of the y-axis. So it's going to be again 22 because we have in this point it's the same as this one. Then it's going to be this point. We have to subtract the 53 minus the 107. So this point is going to be 49 for this point. As we have the same number of the axis of y, we don't have to write G22. We have 2 right now. This point is going to be 11 plus 20 plus 7 is going to be 38 plus 5 that we're going to establish a little up of this point, so it's going to be uh, in y in the same y 43. Next one, I'm going to write this point. This point is in the well, we have in the same axis here. We have 40 plus 7 plus 11 plus 20. So it's going to be in, well, at least for the y-axis, 85, because we have to add 7 plus 20 plus 7 plus 1 was 11 plus 44 is going to be 80 18. So plus the from the 2 is going to be 85. And for the x-axis is going to be this here is 70 plus 7 minus 11 and minus the two, 77 minus 16 is going to be 61. Okay, next one is this point we have to add 11 from the axis this one. So we have to 72 because we have 77 to this point minus the 2 is 72. Okay. And this point is this one. We're just going to up here. We have 70 plus 100,000 minus 5. We have 107 because here we have 105 plus 7 is 112 minus the 2 is 107. Next one is going to be an x34 because we have here 77 minus 48 is equal to x and 34. Next one is this one, and this is located in the same point that we established in the beginning of the code, so it's going to be the same that this one. So with this part of the code, we're going to establish a subroutine that is going to be a loop of 5 times. We're going to add M99 to end the code each time that we save this loop. We're going to come back to the main routine. and we have already marked the points of the perimeter. This code is going to repeat 5 times because it had here P05, but the times I'm going to repeat, and the name of the subroutine. Next one, we are going to add a subroutine in the area. Okay, we have to always go back to the security line in Zeta 1. Always we end the subroutine to avoid to put the field in necessary coding. So we're going to back to the main point that we started here, that is the x12 and 22 in y. We're going to go back to start putting the in this place in the same point that we established in the perimeter. But now we're going to establish the subroutine for the area. We're going to add um, the same code M98 to establish a subroutine. It's going to repeat 5 times, and it's going to be discarded 1881. I already brought these two subroutines to not less time, so I'm going to save this main routine, and I'm going to start the second subroutine that is going to be the area. Is the same for the perimeter. We have to add for the G91 to establish incremental coordinates. We have to have a down of -1, and we're gonna to come back to the absolute coordinates with G90. Okay, this is for area. What I'm going to do here is a kind of repetitive um, code that is going to be passing each time in the code. I'm going to do something like this, and something like this in this part. Okay, obviously no, it's not the sequence that I'm going to do. Basically, I'm going to start uh, coding for this part and doing this one. And at the end, I'm going to add a third part, but I'm going to separate the tool 2.5 millimeters each time. So it's going to be a little repetitive code because I'm going to try to avoid that I have some parts that are not well good. Okay. In this part, we have already that we started in the main point of the perimeter. So we're going to write here G01 plus 5 because we're going to get down first. Next one, we're going to do the same. This the same that the pattern perimeter. Now, because we already marked this this perimeter, this circle, we are going to consider that we have to mark like something like this one, that will let's say this one. We have to separate the 2.5 times. I cannot show it here because the always click here it appears as this square, but the main purpose is to establish 2.5 millimeters each time of the two. So first we're going to go we go, sorry, we're going to go back to x 70 90 19.5 because we have already had here that this point marker, so plus that it was 70, we had a separation of 2.5 in each time. We're going to repeat the same, have to up again, and we're going to go to this point. Okay, we're going to start cutting in something like a diagonal, and for each time it's going to pass 2.5. So okay, why I rolled 36 is because in the previous code we have that it was 34 for this part of the perimeter, so I'm going to add 34 plus 2.5 is 36 0.5 to separate the two. And of course, because we are going to use a diagonal, it's going to be 1.7 because we are in this part. Okay. We have to come back to add two more 2.5 millimeters. I'm going to come back to the x-axis we have here, and we have to add again. I forgot to write 0.1 here. It's not necessary to put it because we are not changing, but at least for this practice we are going to change again. And we're going to add 22 plus 20.5 is going to be 24.5, and we're going to repeat again the same process for each type. We are going to use the same of this one because we already added in the last part, and we're going to come back to 1.7, 107. This is going to repeat each time. Only the axis of x is going to change because we are adding 2.5 each time. So we're going to repeat again. x 40.5 again, because we are here, and um, mm, this one is going to be 1.5 plus, oh, because we have already wrote here, and 22. As I would say, 22 and 107 is not going to change each time. Wait, um, as it is a little repetitive, that the separation of the code, we're going to just add it 2.5 each time. So I'm going to not comment too much because as I said before, I'm just adding 2.5 each time. So it's necessary to comment um, for all the things. Okay, we have here, okay, um, we have here that we already come back for x 24.5 in this part. So we are something like this in this point. Um, so let's say that we are going to come back to over again to add um, 2.5 more. We have to write this one again. I forgot to add in the y of 1.7. Forty 41.5 plus 2.5 is equal to 44, and I have to write again this one. Going to come down again. We're going to add 27 plus 2.5 equals to 29.5. And again, we're going to come back to periphery, this one. We're going to write again this one. Oh, no, let's say 44 plus equals to 46.5. 0.1 0.1 x 175 and y 22. We have to add 2.5 more. So x is equals to 32. Next, we're going to come back to x.5 because we have here and g and y7. We're going to repeat all this time until we reach the this point, and we're going to complete it. We have to read two. We have to add two more. Is equals to 49. 32 plus 2.5 equals to 34.5 and x22. Next one, 49 plus 1.2, 2.5 equals to 41.5. And I don't know, forgot. We had to add first two more to 34.5 plus 21, 2.5 equals to 37. And the same, this one. We're going to add 2.5 more. Mm, I think I have a mistake here because I didn't add it to two more here. The 0.1 plus 4.5. We have to do the same this one and y or 7. 0.1 plus equals to 34. Next, is 0.1 30.7 because I did have this one. 2022. we have to this each time to pass all the pass of the figure. We have to add two more, so it's 42. We have to add here this one again and one corner. And we have here two more. We have to go back to this one and what do we do? We have to add 2.5 more and go back to this one plus the y-axis and the next one is for 56.5 plus 2.5 equals to let's say we're going to stop it here in 40 because here we have already the market this point, so we're gonna stop right here. And at the end 0.5 G's see, and then with the 47 just to stop it here right here. Okay, that we have, let's say, marker something like this, and during the disco we were in this part and we were doing something like this, what we say in the opposite side. We didn't mark, we have to some areas to remark again, so we have to add the at least for this one that is missing and this one that is missing. You're going to the first square. We're going to go down a little bit and we're going to come back a little bit in this part. So it's going to be what we're going to do here is something like this, and also, I mean, for the side of the left side, you can tone down a little bit, and start. Now we're going to subtract each time 2.5 in the x-axis, so we're going to have now x in 69.5 in x. We're going to go down until 87, that is this point. We're going again to subtract two more to this one, 2.5. One. We're going to up again in this one. We're going to subtract two more. We have to go down again. Right. And we are just missing the part of it's going to be in this part down. We have to subtract two more. We have to up again. And let's say that at least for this point, we're going to use this part that is going to miss. So for this part, we have to combine a security line. So we have to be sure that we know the specific size. We're going to go back from something like this point. We're going to get down until G7 because in this part, the part that we are missing in the middle, because in the part we have already marked an over and down of these lines. So that's why we are putting in this side. Okay, we're going to check again. Mm, just missing down. We forgot to put it this. And we're going to go back to until the part of this one. So it's 102 and come back again to the same point. So we're going to save it and start looking for the result. We're going to set view to look more efficiently, and we're going to run the program. This is going to take a lot of time, so um, at least it's going to repeat each time the 5 times the piece. So I'm going to stop the video for a moment and to give you until the machine start to recording. Okay. Now, as this part that we already finished the perimeter of this figure. As you can see here, we have already in the minus 5 in the zeta axis. So we are going to start to doing the area of this figure. As you can see here, it is passing over the part that we made in the beginning. So in this is going to repeat as we program it here 2.5 each time that in the x-axis from this point to this point, and it's going to cover all the area of this figure. Um, Also, and we also added another part for this square, so it's going to stop until the theta comes down to -5. I'm going to stop again a little bit to until the -5 is achieved. So I'm going to show first all the figure, and as you can see here, it's almost completed. Now it's doing the square that we started. We are subtracting 2.5 more. We locate in the same point, and it's going to repeat again. Okay, I'm going to wait until the minus theta in 5, -5 is achieved, and show the final result. And just continuing, we can see here we are in the -3. We have to wait a little more. So the routine is going to repeat 5 times. So this takes a long time. So I'm going to just give it the next under the theta -5. Well, the we already achieved the minus theta in the um, area of the figure. So we can see now here using the 3D view to see the final result. As you can see, we accomplished the figure that we have here. We cover all the in low relief of this figure, and this is all for the video. Thank you very much. My name is Angel Gerardo Zaragoza Costa, and let's see you the next time.